How do I find out the mass of each star separately? How do I resolve the masses of two stars? That can be done too. It turns out that actually the two stars orbit around a point between them that is called the center of mass. Okay, so if I have two stars, one more massive and the other one less massive, actually it turns out that both of them move about a point between them closer to the more massive star. So both of them are revolving around that point, and this is the center of mass, Cm. Now you can understand the center of mass from your experience as a child or entertaining a child. For instance, if you have a seesaw, and there is a toddler sitting on one end, a light kid of mass m, where do you need to sit on the other side so that you balance the child? Well, if I sit on the opposite spot, poor kid is just going to fly off, right? Because I have more mass than him. I have to sit closer to the support point. In fact, I have to sit at a distance so that the center of mass for me and the kid is exactly on top of the support point. And my distance from the center of mass and the kid's distance from the center of mass, which is clearly larger, their ratio is exactly the same as the ratio of the smaller mass over the larger mass. Okay? So then, if I can determine the distances of the two stars from their center of mass, then I have another piece of information. I have one, their total mass, and now I have the second equation that gives me the ratio of the two masses. So I know the sum, I know the ratio, and then I can resolve the two masses. Okay, so from known total mass and the ratio of the two masses, I can find out both variables. And the result of such measurements tell us that basically the masses of all stars fall in a range from about 1/10 of the sun's mass up to about 30 solar masses. Of course, there are stars that are more massive than 30 solar masses, 50, 60, and so on, but they're not very common. And shortly, you'll find out why. Turns out that, and actually I mentioned that before, that the more massive the star is, the shorter its lifetime. It doesn't live very long. Very large mass stars, they don't live very long. It turns out that they burn their fuel at much higher rate, and therefore they expire more quickly.